Hi and welcome to the first lesson of this module where we will see the difference between stateless and stateful processing. So just to recall, previously we saw streaming only in the context of moving data in real time with applying some filters, doing some mappings, and maybe combining incoming records with some referential data set which was stored on on file system or in a NoSQL database. But streaming is much more than that. And this much more than that is englobed in this stateful category, because if you look at it as the use cases you may implement with stateful processing, you will understand how valuable it is. And I hope that I will give you this value in the next slides, where we'll first start by the stateless processing. So as you can see, it's just a pipeline with some basic and simple logic for converting symbols to another format. But stateful processing can also be something like that, but it involves something else in the processing and in the data processing infrastructure. And this something else is the state store. So the state store will be the component that will kind of buffer the values received previously for the purpose of the further computations. Do you need an example? I will give you it just now. So we have our simple pipeline, but we can extend it to doing some counts. So we can count the number of items per color, and as you can see in the state store, we store the counter for the data processed so far. So now when we got one element of each color, we will combine these input values with this state store buffer and generate another value and send it to our sink. As you can see, it's different from a stateless processing when we really consider the data at a given point. Here we keep the reference for the past records in this state store, I would say, buffer for so far. So it opens a lot of interesting use cases. Counter is a very simple example just to illustrate the stateful versus stateless difference. But we can do some patterns detection. You can build you can follow user activity on your website in real time, make some marketing actions in response to some events and stuff like that. And of course, the state store here is local, but it can also be remote. I will show you that in the other modules. I will show you that in the other lessons of this module also. Unfortunately, there is an I/O impact of having this state store in your data processing, because it involves extra communication cost between your job and this component. And if this component is remote, or if this component uses some remote storage for fault tolerance, of course this cost can be painful from the performance standpoint. But the good news is that it's quite easy way to implement interesting and, I would say, session-based or referencing other data business scenarios that has some valuable insight to the end users. So here there are just 3 simple examples that you may implement on your own, and for each one we have some purpose. So when you compute the user session, so how the user behaves or interacts either with your application or with your website, where you can improve the user experience, because you can understand, for example, that users accessing some page or some clicking on some button, they suddenly leave your product. And knowing that, you can of course optimize this user experience. You can also have some marketing actions in response of this real-time activity, like for example proposing a coupon for someone who is about leaving your page or about emptying his basket. So yeah, there's plenty of use cases for that. You can also have some real-time view on your performance by providing periodical stats, like for example monitoring the numbers of your customers, of your users, and suddenly when these numbers shrinks, goes down a lot, it may be a sign that there is something wrong going with your application. And yeah, you can generally implement an alert-based system, mixing some infrastructure part and your business analysis using this stateful processing. And finally, there is an anomaly detection. So as anytime you detect something or something bad, or you detect a user doing some sequence of actions that will or are going to lead to something bad, you can prevent it in a much more reactive way than in batch processing, because yes, you know it, batch is more late regarding streaming, and moreover, when you compare stateful and stateless, you cannot do it in stateless because you don't necessarily store the past values, so you don't have the sequence of events that you need for this scenario. And that's all for this lesson. I hope that you see already the main purpose of stateful processing and that you are very excited to learn more about building blocks, so state store watermark, and also see the use cases and implementations in action. Thanks for watching, and see you in the next lesson.